Hi, and welcome to our fourth module in the greenWORKs webinar series titled Killing Your Building's Energy Hogs, Retro Commissioning and Ongoing Performance. So what we're going to talk today about is how do we actually go about reducing the buildings and existing buildings' energy consumption. So we're going to talk about commissioning and retro commissioning or existing building commissioning and ongoing performance with measurement and verification. Commissioning, when we talk about commissioning, we're talking about a third-party independent verification that the energy systems in a building are operating and performing the way they were intended, the way they were designed. We're talking about the energy-using systems in a building. HVAC systems, lighting systems, domestic hot water systems are usually the ones that we talk about when we're talking about commissioning or retro commissioning. Retro commissioning is commissioning of a building that has not previously been commissioned, where when we use the term commissioning, we're typically talking about new buildings. Retro commissioning or recommissioning is talking about existing buildings. And we'll get into that more in a little bit. Energy auditing we covered in detail in the last couple of these webinars, going through your building and evaluating where you can reduce energy through energy conservation measures. Net operating income improvements is kind of an offshoot to energy auditing where you implement the recommendations from an energy audit, start recognizing those financial savings, and then applying that money, those financial savings, back into the building for capital improvements to save even more energy and keep that cycle, that circle going. And measurement verification is we want to measure within a building where we're using energy and how much we're using so that we can better target energy conservation measures and further reduce energy use. So I always say that the two biggest things that you can do to improve your existing building's energy performance are commissioning or retro commissioning and measurement verification. These are the two biggest things that we can do to guarantee ongoing operational energy performance. It's one thing to design a building to operate efficiently. It's quite another to make sure it actually operates to its potential. So we talk about basically a very simple three-step approach to energy conservation, whether it be in new buildings or usually in existing buildings. And step one, make sure that when things are supposed to be off, that they're actually turned off. We go into a lot of existing buildings during the evenings and to do a night walkthrough to really assess the performance of the building when the building's unoccupied and find that there's lots of things that are on that really don't need to be on since the building's not occupied. So make sure it's actually off when it's supposed to be off. The second one is that when things are on, to make sure they are operating properly, operating the way they're supposed to. So when equipment is on, that it is not operating inefficiently, heating and cooling, running at the same time, full out, ductwork, leakage, things like that. And then after you've done number 1 and 2, make sure that things are off when they're supposed to be, and when they're on, that they're operating the way they're supposed to be. That's when you start looking at, is there a better way? Are there improvements that we can make to the building? Can we upgrade the lighting? Do we have old HVAC systems that we can recognize energy savings if we replace them? Are there opportunities to improve the building envelope with new windows or roofing? Controls, building controls is a thing we get into quite a bit. Do we have an antiquated control system? Can we recognize energy savings by replacing the control systems, and so on and so forth. So first we want to make sure what's there is operating the way it's supposed to, and then we start looking for ways to upgrade and improve the systems. So I referenced this Berkeley Labs study a couple of these modules ago. I want to talk about a couple different charts here today. So Lawrence Berkeley Labs did an analysis of over 643 buildings over 10 years and documented all of the different energy-related problems that were observed in those buildings and analyzed the costs and the savings associated with those improvements. And basically found that There's quite a bit of energy savings to be achieved, both in new buildings and existing buildings, and that those savings usually result in a very short payback, somewhere in the 1 to 4 year range. So this graph is showing cost savings and paybacks for new building commissioning. So for commissioning a building that has, is just being built, what are the opportunities for savings? So the commissioning cost being down across the bottom, and the energy savings on the vertical axis there. You can see in this example that included about 36 projects. Where you want to be on this curve is in the upper left-hand quadrant, where we don't spend a whole lot of money on commissioning but recognize a lot of savings. Savings on new building commissioning in that 5-year range with some outliers. Where there's a lot more opportunity for savings is where we're using more energy in the first place. So high-tech buildings that have complex and sophisticated HVAC systems and use a lot of energy to begin with can recognize bigger savings. So if you've got a healthcare occupancy or a lab, a building that uses a lot of energy, there's more potential for savings than for an office building or a school or a hotel that isn't using that much energy in the first place. And since there's going to be some base fixed costs anyway associated with going through commissioning or measurement verification. So down along the bottom graph, you can see those the buildings, labs, and healthcare facilities that use a lot of energy have a much lower payback time, less than a year, compared to some other buildings. And then this chart is similar to the first chart and the scatter chart, showing the commissioning costs versus energy savings for existing buildings. And you can see that on the scale here, these lines are much shorter payback periods. You still would like to be in the left-hand side of the upper left-hand side of the graph, but you can see that for existing buildings, the payback periods were mostly in that 6 month to a year time frame. For retro commissioning or recommissioning activities of existing buildings, and as we've talked about in some other of the webinars, there's a lot of low-hanging fruit that we can go after just by going back into a building and making sure that things are operating the way they were intended, which is, of course, the goal of commissioning. So I like to cover the commissioning process and emphasize that it is a process, not an event. Some people think of commissioning as just a single event that happens at the end of the job when you come in and do the functional testing of the systems. And really that's just one element in the whole commissioning process. Good commissioning starts at the earliest design phases, where the commissioning team is selected and brought into the project as part of the overall design and construction team from the earliest phases, representing the owner's interest, the owner's QCer or third-party verifier, if you will. So in the pre-design and design phases, where the commissioning agent gets involved with reviewing the owner's requirements and the basis of design documents, starts developing the commissioning plan based on the design reviews, the reviews that they're doing of the design documents, and working with the design team to make sure that the design is meeting the owner's goals, the owner's project requirements. That's the basis for any commissioning process, and that the systems will be able to be maintained and operated properly. So in a design review, we'll be looking for things like, can we get to the equipment? Is there access to it? Will we be able to maintain it properly? Because if the systems aren't going to be able to be maintained, then they're not going to operate efficiently for very long. Then in the construction phase, their commissioning agents do routine site observation, conduct commissioning meetings with the team, make sure everybody's on board with the goals of the project and the goals of commissioning, and they work with the contractors and subcontractors on the startup testing and planning for the functional testing. The acceptance testing is really where most of the effort goes into the commissioning process. That's where all the functional testing is done. that most people think of as commissioning, that's the bulk of the work. So working with the contractors, implementing the commissioning plan that was developed, saying, here's how we're going to test all of these systems to make sure that they are operating properly. Those tests are documented and verified and signed off on, and those forms ultimately are kept as part of the final commissioning report. The owner and the building operators could go back and recommission the building using these same forms and same processes, knowing how systems were supposed to be operated. After the functional testing is complete and everything is working correctly, they move into the building. During occupancy, we make sure that the staff training is happening. A very important part of the commissioning process is to make sure that the building operators, the people who are going to actually operate and maintain the building, are part of that commissioning process, not just during the functional testing, but all through the process. And then we make sure that the staff training is documented and verified. If there is any functional testing that needs to be completed for whatever reason, because the system wasn't done or wasn't ready to be tested before occupancy, or off-season testing, if the building is completed, for instance, in the summer, then we'll want to come back in the winter and verify that the heating is working the way it's supposed to. And then during what we call the post-occupancy phase, typically we'll do a walkthrough, a 10-month walkthrough, sometime before the 1-year warranty phase is up, just to make sure that everything is done and verified, see if there are any ongoing issues with the building and its operations, interviews with the operations staff, and just see how everything is going on. And we'll talk about recommissioning, or ongoing commissioning of the building, because we want to make sure that the building is not only operating the way it's supposed to now, but continues to in the future, because without continued attention and recommissioning, pretty quickly the building will revert to a state of chaos. That things just change over time, settings get overridden, and pretty soon, before you know it, the building is not operating the way it was intended, and energy performance starts to decrease. So there's some misconceptions about what commissioning is and what commissioning is not. It's not just a matter of filling out some forms. Commissioning is really third-party, independent verification. So while we work with the contractors a lot, we are not, some type of inspector. We're not just making sure that the test and balance is done. It's certainly not a substitute for the contractor's QC program to make sure that they've done their jobs. Contractor still needs to go through and make sure that they've done their portion and things are working to the best of their knowledge the way they're supposed to before we come in and do functional testing. And that should just be a verification of that. Commissioning is a process that spans the entire length of the job, just not somebody coming in with some checklists at the end and filling out a little bit of paperwork and submitting it. But when commissioning is done and the building's occupied, like I said, we are not done thinking about energy performance. Measurement verification is really one of the most important things we can do. Again, measuring where we're using energy and how much energy we're using there so that we can target energy conservation measures. It's really just a matter of actually going back and looking at energy performance on a regular basis. People don't, even when they're looking at their energy bills, they are not, paying their energy bills, they're not really questioning, I wonder why our energy usage went up this month. It's really the biggest thing that they can do to start identifying potential savings. So there's some components to the measurement verification plan, both from a lead requirements standpoint, but also, and more importantly, from a can we actually use an M&V plan, a measurement verification plan, to help us reduce energy usage on an ongoing basis. So the IPMVP, the International Performance Measurement Verification Protocol, is kind of the baseline standard guideline that we use for developing measurement verification plans. talk about here is mostly based on option B, which is the energy conservation measurement verification approach. Basically identifying how much energy did we expect the building and these various systems within the building to use. What was the baseline? What did we expect those numbers to be? And then having the tools, the meters and monitors and capabilities within the building to be able to isolate whether it be how much lighting energy are we using, how much heating energy, how much fan power energy, how much cooling energy, to really get down to those major energy users and quantify how much energy they're using every month, let's say. So then every month we go through and we compare what the expected value was. We expected to use 100,000 kWh of lighting energy. We actually used 150,000 kWh of lighting energy in this month. That's more than we expected, a lot more. So why is that? And with that information, you can start to go and answer those questions. Why are we using more energy than we expected? We verify, the things were installed properly. Maybe the occupancy conditions have changed. Maybe the operating conditions have changed. Maybe something's just not working right. Maybe the control systems aren't turning the lights off at night like we thought they were. Gives us the power to go and investigate. That's a key part of the measurement verification plan, is set those parameters, and then the step-by-step, okay, if we find that we are more than 10% out of what we expected the energy usage to be, what do we do? Step 1, Step 2, Step 3, Step 4. And then once we've gone through whatever those steps are, maybe the answer is that no, everything's working the way it's supposed to, and our baseline expectations were too low. And if you continue to track month after month, then you'll see that the energy usage is following along this consistent path and everything's working the way it's supposed to, well, then you can reset the baseline, either up or down, again, knowing what to expect, and then what to do if it deviates from those expectations. That is really the key to measurement verification. And then one key part of a measurement verification plan, besides the doing it on a regular basis and verifying those numbers, is the commitment to do it for a long time, typically for at least a year. Of course, the best thing you can do is to implement and continue to do measurement verification for the life of the building. Submetering is one of the keys to measurement verification. Again, if we don't know how much energy we're using and where we're using it, then we can't address these items. So we kind of say that when in doubt, put a meter on it. You want to tackle the major energy users in the building first and try to submeter those systems, whether it be lighting or heating or cooling. If you can capture 80% of the building's major energy usage, then you're doing pretty good. So you want to pick and choose where you're going to put your meters, because there is cost associated with it, and you don't want to necessarily drill down so far down to the minutia level where you're really starting to lose the amount of benefit that you get from that level of detail. But knowing the energy usage, it can certainly help you predict future events. Gives you real-time information, and with information there is power. So after we've commissioned the new building and have an ongoing measurement verification plan, we still want to continue a existing building commissioning program. Retro commissioning, that term implies that we are returning a building to its previous operating state, that we're turning it into that retro state where it was originally designed and originally intended to operate. But maybe there's a better way. Maybe the way it was originally designed isn't the most efficient way that it can be operated. So we don't want to just necessarily turn it back to the way it was supposed to. Once you've commissioned the building or retro commissioned it, developing a plan to a recommissioning plan, an ongoing commissioning plan to continue to test all of those systems every 2 to 5 years is a good rule of thumb. Will do wonders to keep your building performing as optimally as it can. So one strategy you can do is that you don't have to swallow the whole thing at once. You could set up a program where every 6 months you are testing and recommissioning 1/4 of the systems in the building. So then that puts you on a cycle that every 2 years you've addressed the whole building. That's just one strategy. Or you can wait till every 2 or 3 years and just tackle the whole building at once. The important thing is having that plan and implementing it to keep checking to make sure that the building's operating how it's supposed to. The process for existing building commissioning is a little different than for new building commissioning, but again, it is a process. It's not just a one-time event. Typically, there's an investigation and analysis phase where you'll go into, especially if the building's never been commissioned before, where you go in, understand the systems, start developing the plan, benchmark the current performance. If you're doing a measurement verification program already, then you're going to already have that benchmarking data. But if not, getting the 12 to 24 months worth of energy bills and benchmarking using Energy Star Target Finder or some other method is a great way to start. We've covered that in the last couple of greenWORKs modules, so I encourage you to go back and look at those. We develop an existing building commissioning plan where we create the procedures and the forms, testing protocols in which to go through and systematically test and verify all of the equipment and the systems to make sure they're operating the way they were supposed to. One of the things when you're going into an existing building to do existing building commissioning that's different from new construction commissioning is there's not a contractor on board or subcontractor, so you have to typically engage a test and balance firm and a controls contractor to help with the verification, verify the airflows and water flows and help make changes to the controls programs. Whether the owner has one on board or not, or you have to engage one, that can be they're important people in the functional testing and acceptance testing procedures. So you need to get them on board, go through the functional testing, verify what's working and what's not, reset, reprogram, make the corrections needed to get the building operating as efficiently as it can be. And then after the testing, certainly the documentation of the reports and the forms that were completed to make sure that we've got good documentation that can be then repeated if needed be and included into the ongoing or recommissioning plan and schedule. Documenting all that is very important. That about wraps up our quick overview of commissioning and measurement verification and ongoing performance. I encourage you to go back and re-review any of the other greenWORKs modules where we've talked in more detail about energy demand, energy auditing, and benchmarking, and hope you have enjoyed this series. Thank you.